Hello and welcome everyone. I'm so excited to start this brand new and a properly structured series on AQA GCSE for the maths. Whether you're preparing for your exam or just looking to build strong your mathematical skills, this series is designed just for you. Well, this is a very systematic and well-planned, structured in a way, like this whole series is structured in a way that will take you from the foundation of each topic to exam level problem solving. You don't need to look anywhere else, no extra practice books, no other videos, because this series has it all, including worksheet solutions and detailed explanations in every step. In this very first video, we will be starting with the topic that we already aware of, that is Surds. On the screen, you can see these are the topics in your AQA GCSE for the maths. Here we are specifically working for further maths, and since you have taken further maths, so I assume you are already aware of the basics. So instead of starting from the basics of numbers, ratio proportions, basics of algebra, I'm starting with the Surds. Whether it's about the simplifying expression, rationalization, solving tricky algebraic question involving surds, we will definitely master them all and we'll see how to solve them step by step. Well, in this video, I'll be covering the theory, but in the next video will be practice with carefully selected worksheet. The very first thing and the surd that I'm going to start with, which I said that I'll start with a very scratch, will be what are surds. And second is, why are they irrational? Why do we call surds irrational? So the first thing is, a surd is a root number. It can be a square root, a cubic root, etc. That means if I'm writing root 2, that's called square root of 2. Or I'm writing cube root of 3 here. It's 3 represents cube root of 3. And another way of understanding is root 2 is actually 2 to the power of half. These are actually the fractional powers. So root 3 is 3 to the power of 1 by 3. Or root 5 is 5 to the power of 1 by 2. So we can say surd is a root that cannot be simplified to a whole number or a fraction. That means I cannot write it into an integer number, or I cannot write it in a fraction number. I can't say that root 5 is like 10 over 3, 2 over 5, or anything that cannot be represented in a fraction or as an integer. That is actually your surd. Well, the question is, what makes a number irrational? So a number is irrational if it cannot be written in a fractional form, which I just explained. They cannot be written in a fraction form. P by Q, they cannot be written in this form. Not possible. And second thing is, in its decimal form, when you are going to convert them into a decimal form, say for example, you have used a calculator and write root 5, you will definitely going to have some answer in decimal. But when you convert it into decimal, it will be a non-terminating and non-repeating. That means, take an example of root 2. If I talk about the value of root 2, it's 1.4142135, and it goes on forever with no repeating pattern. So it's not going to terminate at any point. It's endless and no repeating. There is no repeating pattern that you can see. And such numbers are called irrational numbers, and surds are basically the irrational numbers. So this was the basic of the definition that we have studied. Now let me move on to the operations that definitely we are going to see on the paper. Obviously, starting with the very basics. That means how to add the surds, how to multiply the surds, and so on. So our operations start with addition of surds. First and important thing is we can add like surds. Like surds, that means root 2 plus root 2. These are like. They look same, root 2, root 2. And how many times are there root 2? 2. 1 plus 1. That means it will give me 2 root 2. So, which makes our first rule, which deals with the addition, root a plus root a is equals to 2 root a. On adding the roots, we can add the similar roots. So what we can do, we can add similar roots. similar surd numbers. Whereas if I have to add two different surd numbers, I can't do anything. Say for example, it's root 2 plus root 3. I can't do anything for this. These two are entirely two different surd numbers. I can't add them. So it's just root 2, root 3, that's it. Second is, similarly, I can subtract that. Take one more example of addition of surds before I move on to the subtraction. Say for example, it's 13 root 5 plus 4 root 5. So what I can do, 13, their coefficients, add their coefficients. You can think surd as algebra when you're going to add it. If it's 13x plus 4x, what we do? I'm adding 13x to 4x's. That means it will give me 17x. Similarly here, it will be 13 root 5 plus 4 root 5. That means 13 plus 4, 17 root 5. And this is how we can add our surd number. Moving on to the subtraction, it works the same. That means if, say for example, if it's 3 root 5 minus 2 root 5, again you can treat it like an algebraic term, like 3x minus 2x will give you just single x. Similarly, you are subtracting 2 root 5s from 3 root 5s, so answer will be just single root 5. That will be the answer. Or simple, keep that in mind that we have to subtract only the coefficients. Third one is that deals with the multiplication. Now, the third one deals with the multiplication. Well, in your syllabus, it's only the square root, not the cube root or the higher root. So we are just only sticking to the square roots. So if we are multiplying two square roots, it will give you, let's say, root a times root a will give you just single a. If it would be a cube root, then it will be 3 times. Whatever be the number here, that number of times you have to multiply to get a single integer. But since I told you that's in your syllabus, so we'll be sticking to it solely. So root 2 times root 2, because there is a root and we are multiplying it 2 times, so it will give me just 2. Similarly, root 5 times root 5 will give me 5. Now, if the multiplication is root 5 times root 5 times root 5, we are multiplying it 3 times. So when I'm multiplying it 2 times, it will give me just single 5 and then root 5. So this is how, because we can't do anything in that case. 5 multiplied by root 5, a number and a surd will be written like this. Similarly, we can see if we are dividing the same root numbers, like root a over 2 root a, I can cancel them out easily. So that means root a and root a will be cancelled out and remaining will be just half. So this is for the same surd number. And there's another way to clear it. Why? When we multiply two same surd number and it will give me an integer, because as I told you that root means the power is half. So when you're multiplying root 3 times root 3, it's actually 3 to the power of half times 3 to the power of half. In indices, we have studied when we multiply two indices having the same base number, the power gets added. So the base number is same, which is 3. That means power will get added. That is 3 to the power of 1. That will give me 3. So this is another way to understand this. Or we can just learn this thing, that since it's a square root, so when I'm multiplying two square roots, it will give me the integer. If the two numbers are entirely different, two surd numbers like root 3 times root 2, I can write root and 3 into 2, 6. That means our third rule, our fourth rule you can say, deals with the multiplication of two different numbers. Root m times root n is equals to root of mn. Same thing we did here. Taking one more example, like say 6 root 6 times, let's take another, let me say root 6 times root 3. So that will give me root 18. Well, later when I'll teach you the simplification of surds, I'll teach you we can simplify it further. But as of now, keep in mind when you are multiplying two different surds, you just have to multiply them together just like this. Fifth one deals with the division, which I just gave the example. If the same surd number is there, like root m over root m, I can get 1. Or root m over 3 root m, I can cancel it up and I'll get 1 over 3. Similarly, suppose it's given as root m times root m over m, I still can cancel it out and it will give me root m. Now, after the basic principles, or we can say the rules, we are doing simplifying the surds. That means writing the surds in more simplified form. Say for example, this one is root 30. So in simplification, the very first thing that we have to do is finding the prime factors using factor tree method. So 30, there are two ways. Either you can make two branches and keep on finding the prime factors, or we will start with one on one of the three. We'll be writing the prime numbers, and other, that's the division or the simplified number, which means 30, the smallest prime number that divides 30 is 2. So I'll write 2 here and encircle it because it's a prime number. And here on the other branch, I'll be writing 30 over 2. So with 15. Why? Because obviously when I multiply these two, I'll get 30. That's the meaning of it. Again, because 15 is not a prime number, I can further divide. So the smallest prime number that can divide 15 is 3. Encircle it. And 15 over 3 is 5, which is also a prime number. So I'll be writing 5 times 3 times 2. In order to simplify, we have to find the pairs. If there's no pair, you can't simplify it. That means root 30 is root 30 itself. If it's confusing, let me show you one more example, which is root 45. If I use the prime factorization using factor tree method, 45, the smallest prime number that can divide 45 is 3, and here I'll be writing 15. Again, 15 can be divided. The smallest prime number that can divide 15 is 3 and 5. So these are all prime numbers, that is 5 times 3 times 3. So root 45 can be written as 5 times 3 times 3. Now I have to take out the pair 3 and 3. They are in pairs. So I can take out it as it is, that means 3. Don't take out 9. 3 is in pairs, so I'll take out 3 out as common, and root 5 will be remaining as it is because it's unpaired. And this is the simplified form, so root 45 can be written as 3 root 5. Now again, why have I taken 3 out as? Because root 5 means root 5 times 3 times 3 means root 5 times root 3 times root 3. This can be written like this. And we just studied that if you are multiplying two root numbers together, the number itself will be the answer. That means root 3 times root 3 is 3. So answer is 3 root 5. So simple, rather than doing and making them more like whole things more complicated, it's better we'll find the pair right there and write 3 out, and which is unpaired will remain inside the root, and this is how you simplify it. Let me do one more question. Let's say root 120. I'll find the prime factors again using the factor tree. So smallest prime number that can divide 120 is 2, and here I'll be writing 60. 60 is not a prime number, that's why again I can divide it into two parts. Smallest prime number 2, and here I'll be writing 60 over 2, which is 30. 30 is not a prime number, still it can be divided. The smallest prime number that can divide 30 is 2, and here it's 15. And again, for 15, I'll be writing 3 here and 5 here. So now 120 can be written as 1, 2, 3, 3 times 2, 1 times 3, and 1 times 5. I have to take out the pair. 2 is in pair, so writing 2 out. And these all are unpaired. That means this is 30, so root 30. So 120 can be written as 2 root 30, and that's the simplest way of solving it. So that's it for today. In the next class, we'll be doing questions and also the rationalization, and we'll be doing questions from simpler to harder to very hard. So that's it for today, and also I'm starting the new batches, new GCSE batches, so which are just at £6 per hour. All you need to do is drop us an email at akzsi@gmail.com. And also, if you're looking for classes from year 1 to A levels for any subject, we have a panel of experienced tutors, so you just need to send us an email to book a free demo. And also, if you're looking for the free worksheets, they are available at akzsiacademy.com. Bye, take care.